Okay, part 3. I know this is a long chapter. The other chapters are shorter. Okay, so protection of the brain. Okay, obviously the brain is the most important thing to protect, which is why it's in case of so much solid bone. Okay, so the first thing that protects it from injury is the bone. So if I drill into your skull, once I get past the skin and the fascia and all this stuff, I hit bone. Okay, but underneath that bone is more stuff. Okay, there's the skull, okay, the bone, the meninges, and then the cerebrospinal fluid, and then finally the BBB, the blood-brain barrier. Okay, all right, the meninges. The purpose of the meninges is to protect and cover the CNS. Okay, is to enclose and protect the blood vessels that supply the CNS. It contains the cerebrospinal fluid, which flows between the Pia and the Arachnoid Maters. Okay, the outermost layer of the meninges is the Dura Mater. Okay, Dura actually means tough. So, and you'll see what the Dura Mater is in that video. It's kind of a softer layer, but it's pretty tough. It's not easily tearable, and that's an important thing. Okay. Don't worry about the two parts of the Dura Mater, but the outside layer is the Dura Mater. Okay. Okay. So the Dura Mater actually folds into the brain here. So in the places where you have the fissures, you have like slices of Dura Mater going in. Okay. Okay. The second layer is the Arachnoid Mater. Okay. The arachnoid has a texture kind of like spider webs, which is why it's called Arachnoid Mater. Arachnoid being spider. Okay. Okay. And then the last layer is a Pia Mater. The Pia Mater literally covers the surface of the brain, and it's literally right on the surface. So you won't be able to see that in any video. It's too thin to show. Okay. All right. The cerebrospinal fluid, okay, or CSF, okay, is formed. So let me show you. So it's actually formed in the brain. So you have blood vessels going through, and the blood vessels go through here, and fluid leaks out of the blood vessels, and that's collected as CSF. So it has basically everything that blood has, except it's cleaner. It doesn't have any of the cells and viruses or any of that stuff. It's a fluid with the sodium, sugar, ions, and stuff like that. Okay. Okay. And then it flows around the brain. Okay. So you see it floating around the brain. Okay. So one of the things I want to point out, the narrowest part is right here. Okay, the cerebral aqueduct. And this can be actually plugged and sealed accidentally. Okay, and it can cause, like if you, in adults, if you plug that, you can cause tremendous brain damage and even death. In children, in babies, actually, it causes something even weirder. It's called hydrocephalus. Hydrocephalus is literally means water in the brain. Because the skull bones are fully formed, okay, they're not solid, that water can expand. Okay, you're constantly making fluid here. If it doesn't drain out, okay, and drain back into the blood, it just builds up in the brain. Okay. All right. I showed you guys the astrocytes last time. They help form the blood-brain barrier. They help blood-borne toxins from entering the brain. These capillaries are all wrapped up, and therefore a lot of drugs that can enter your bloodstream cannot get into the brain. And that is both a good thing and a very bad thing, because the fact that a lot of drugs don't get in the brain protects your brain. But when you want drugs to get in the brain, like, you know, antibiotics or cancer medication, scientists have a very hard time trying to get it into the brain. Okay. All right, the spinal cord. Okay, the spinal cord runs through the vertebral canal. Okay, it does not run all the way down your spine. It actually ends at about L1 to L2. Okay, the end of the, let me show you the spinal cord. So that yellow structure all the way down to that point is the spinal cord. The end of the spinal cord ends in something called the conus medullaris. Okay, so it comes down and ends in this cone-shaped thing. What extends out of the cone-shaped thing is the cauda equina. Cauda tail, equina horse. It looks like a horse's tail. I thought they had a picture. I think they have a picture in the textbook where you actually see the cauda equina, and it looks like a horse's tail. Okay. All right. So here you can see what the spinal cord actually is. There's a spinal cord, and here are the spinal nerves that come out of the spinal cord. Okay. Okay. The parts of the spinal cord. There are two deep grooves. Okay. The anterior side is deeper, and therefore it's called a fissure. The posterior side is more superficial. It's called a sulcus. Okay. So here is the spinal cord. Okay. First of all, you have white matter on the outside, and you have dark matter on the inside, or gray matter on the inside. Okay. You also have the meninges around it. Okay. So the same three layers: the Dura Mater, Arachnoid Mater, Pia Mater. Okay. Okay. Now that's important. I want to show you what the horns are. The horns. Okay. So if you look at the gray area, the gray matter here, there are three horns. Okay. The dorsal horn in the back, the lateral horns on the side right here, and then the ventral horns in front. Okay. The dorsal horns is going to be sensory information. The ventral horn and the lateral horn is going to be motor information. Okay. You don't have to tell the difference between somatic and sensory, but you have to know that dorsal horn is going to be sensory information, and these two horns, the lateral and the ventral horns, are motor information. Okay. Okay. So there's the horns coming in. Okay, this is the little spinal nerve. These two are called the roots. Okay, so you have a dorsal root, which is sensory information, and you have ventral root, which is motor information. We'll cover this again in the next topic when we're talking about spinal nerves. Okay, all right. The protection of the spinal cord is protected by the same three things: the Dura Mater, Arachnoid Mater, Pia Mater. Okay. Okay. The cerebrospinal fluid also, what protects your brain actually protects your spinal cord as well. Remember, the spinal cord and brain, we think of them as two different structures, but they're actually one long structure. And it really is just a tube that is extended at the top end. Okay. Now here, okay, you can see this is a procedure called a spinal tap. If I wanted to access to your cerebrospinal fluid, if I was checking for meningitis, for example, okay, I want it to come in here and extract fluid. So the spinal cord ends right about there. That's the end of the spinal cord. And so if I insert the needle here, I can access into the puncture the Dura Mater here and puncture the Pia Mater here and get into here. But all I have are little nerves here, but there's no big structure. So I can, like, the nerves can move aside, so I can puncture into there, extract cerebrospinal fluid without risking any damage to the spinal cord. Okay. All right. We'll skip the pathways, ascending, descending pathways. All right. The damage to the spinal cord. Okay. These terms you do have to know. So paralysis is a loss of motor function. Okay. Paresthesia is the loss of sensation. These are two different things. Okay. So so let me show you the spinal cord again. Crap. Okay. So if I cut the back side of the spinal cord, I lose sensation per paresthesia. If I cut the front part of the spinal cord, paralysis. Okay, I don't necessarily have to cut all the way through, so I can get paralysis without paresthesia and vice versa. Okay, if I cut through both, then both. Okay. All right. Paraplegia is the loss of upper limbs, or sorry, lower limbs, so you still have functional upper limbs. Quadriplegia is the loss of all four limbs. Okay, so injury to the spinal cord in the cervical region, because you'll learn later your arms are controlled by the lower part of the cervical region and the upper part of the thoracic region. Okay, so between T1 and L2 there'll be paralysis of the lower limbs. Above C5 actually is going to be quadriplegia. Okay. All right. A stroke, okay, is just an interruption of blood supply, blood flow to the brain. Okay. Alzheimer's is a progressive degenerative disease leading to dementias. Okay. So, like I said earlier, some development occurs in the early 20s. The anterior lobe of the anterior portion of the frontal lobe. Okay. Okay. All right. That ends this presentation. We'll go over it. Okay. In class